Okay, and we're live once again. I have just finished fiddling around with a little bit of code, and then I remembered that I wanted to take a look at something I did. I questioned back here why we needed write storage for the player if we're only getting position for, and we're only changing the position, we're not changing the player. So I'm going to try that now to see if it's possible to make that a read storage so that I pretend I can understand what's going on. Does this still work? Let's build it. Build. Doesn't satisfy fetch. Oh, because I have a mute players. Okay. Let's see if that right here. I don't want to have mute players. Right? Let's do this in the same order so everything looks good. Can I build that? And now we don't need a mute there, right? So delete that, try again, and hopefully Clippy is happy. Okay, and does it work? So let's bind gen and reload. And yeah, so we didn't need write storage for that. So that must be something that's coming up later in the tutorial, which we will get to, and then something's going to fail and we're going to scratch our heads. But meanwhile, cargo format shouldn't make any changes, right? Oh no. Oh no, it's the same. Okay. I got confused for a second. And then we can commit this. We commit, I have to add it first. Git add source, git commit player storage read as read only. As read only. All right, so the other thing I want to do is take a look and just grab these two lines and create a build script. So I don't have to keep typing them in every time. Right? Modify build, and now I can just build it this way. Oops. What do I do? Oh, there's a \n on that. How did that happen? Good. Okay. Yeah, build, git commit simple build script. Probably want to do an and in there, right? And that. Something like that. Sure. It should still work. And git add, git commit, simple build script. Done. Okay, so that makes things a little easier to still works. All right, so we're done with entities and components, and now we're going to say walking a map. Blah, blah, blah. Defining map tiles. We'll start by allowing two tile types, walls and floors. We can represent them with an enum. Tile type, wall, and floor. Okay. I guess we'll expand on it later when we have more things, but for now, oh, and they're not components. So these up here are the components, and this is just the world. So let's put a little line between these guys and say derive partial EQ, copy, clone, enum tile type wall floor. We'll let cargo reformat that for us. Right, we've added copy and clone. Yep, partial equal allows us to use equal and not equals, and then building a simple map. Okay, so now we'll make a function that returns a vector of tiles representing a simple map. We'll use a vector size to the whole map, which means we need a way to figure out which array index is at a given xy position. So first we make a new function xy_idx. Oh, so given an x and a y, we return offset into an array. Or an offset into, a one-dimensional vector. Bub fn xy idx yi32 returns a u size, y as u size times 80 plus x as u size. I'm going to refactor that a little bit. Y times 80 plus x as u size. That should work too. Simple, it multiplies y position by the map width and adds x. This guarantees one tile per location and efficiently maps it in memory for left to right reading. We're using Rust function shorthand here, right? Function returns u size. Right, that's the... I think didn't we do that earlier? Yeah, we did that here with the return statement. Interesting. Okay, so then we write a constructor function to make a map. So we're going to make a brand new map using this xy_idx. All right, so let's actually put state down here, and then we can copy this. And this section will be for maps. Map section. And at some point we'll refactor this into separate files. World state section. And this is the component section. Component section. All right, and then fn new map. I'm going to return a vec of tile types. Just one type. All right, so let mut map is equal to a vector of floors, and we have 80 by 50 floors. And now we're going to make the walls, make the boundaries walls. For x in 0.80, map of xy idx x0 is equal to equal tile type wall. And we'll do the same thing for 49. If I could type, I'd be dangerous for y in 0.50. And then we'll just do the same thing here, except we can pass in y and 0 and 79. Right? We'll randomly splat a bunch of walls. Oh, this is where we're using the random number generator. Okay. Let mut RNG is equal to RLTK random number generator. Got it? For I in 0 to 400. We're going to call roll dice twice. We're going to pass it into IDX. And then if the index is not equal to 4025, which is where we put the player, then we put a wall there. Okay, that makes sense. So I'm going to do fancy schmancy RNG roll dice 179 and 49. And then let the index equal to XY index, XY. And then we're going to compare it to XY index of, so we'll just call it here, let player pause is equal to XY IDX 4025. That way we're not calculating every single time through the loop. If IDX is not equal to player pause, then map of IDX is equal to tile type wall. And then we return the map. Very good. Okay, so yes, and then going over rusty stuff, which I'm familiar with. So I don't need to relearn that. But now we need, okay, specs. This is that crate we're using. We're using a specs crate as well as an RLTK crate. So at some point I keep promising to go look at specs and see what that's all about. Because specs looks like it's implementing the ECS part and RLTK is giving us the GUI or the user interface part. So we still need to go through and add a new map to the world. GS ECS insert new map. We can just do that. Just insert random. Because this, what is this map returning? It's just returning a vector of tile types. And when we're inserting it, the world doesn't need to know. There's nothing up here saying adding knowledge of vectors to the world. So we're just inserting. Map is now available from anywhere the ECS can see. Now inside your code you can access the map with a rather unwieldy let map equals self.ecs.getMute : vec tile type. Okay, it's available to systems in an easier fashion. There's actually several ways to get the value of a map, including ECS get, ECS fetch, get mute. In terms of mutable, you can change it, reference to a map, wrapped in an optional, in case the map isn't there. Fetch skips the option type and gives you a map directly. We can learn that in the specs book. Okay, at some point we're going to have to take a look at this specs book. They keep mentioning. Oh. Go back to the introduction. Okay, but not now. All right, so now we have a map available. We should put it on the screen. The complete code for the new draw map function looks like this. So we're given a map and a context. We're going to loop over every entry in the map. Oh, I see. We're just manually keeping track of the XY location. And then we set it either to a dot for floor. So floor gets a dot and a wall gets a hash tag. Okay, we can do that. So we're still in the map section. I guess it doesn't have to be public. Function draw map, map tile type. So this is a slice instead of a vector. Mute RLTK. So at some point we're going to have to convert from a vector to a slice, but I think Rust does that automatically or has an easy way to do it. We'll find out. Y is 0, X is 0 for tile in map.iter, match tile. If it's a tile type floor, then we're going to use ctx set xy. Can we reuse this value? We're passing it in here, but do we have to create a different one for every tile? RGB, I'm thinking is pulling it out of the loop again, F32, 0.5, 0.5, 0.5. And then we'll do the same thing for the background. It's just 0.0.0. Right? And then we're going to do this. And again, I think we should be able to just create it once. But I don't know. We'll find out. All right, so then we do the same thing for the wall. Okay. Wall, and the wall is going to be a different color, different background color. Zero, 1, 0, and then oh, that's foreground. Okay, foreground and background. And then the wall is going to be a hashtag. Right? Boom. And then we just manually increment x, and if x is greater than 79, I'm going to set x equals 0 and y equal to incrementation, and we're going to let cargo format clean that up for us. All right, so that draws the map. That makes sense because we're just iterating over everything, and then we're just putting xy coordinates in our set function, which is similar to the this one here for drawing all the renderables. Now, the map is apparently different to a renderable because it's living outside of this entity component system thing. Okay. It's mostly straightforward and uses a concept we've already visited. In declaration, we pass the map in as that instead of a vec. So it allows us to pass in slices of a map. We won't do that yet, but it may be useful later. Foreshadowing. It's also considered a more rustic way to do things, and the linter warns about it. I already know about slices. Otherwise, it takes advantage of the way we're storing our map, rows together one after the other, so it iterates through the entire map structure. Yep. And now we should also call the function. In our tick, we're going to add a call to draw the map. So, I assume after we clear the screen, let map is self ECS fetch vec tile type. So it fetches whatever was inserted into the world that has that type. And since there's only one, we only get that. Draw map. And we're passing a reference to map with the context. And here's the thing, is we're passing a reference to a map, and map is a vector of tile type, and Rust is automatically converting that into a slice for us. All right, so now that it's drawing, it doesn't say to run it, but I want to run it and see what this looks like. See if it even builds. All right, I forgot to close the match. I also forgot to remember what line that was on. Okay, yep. So these go here. Put that like that. Builds. Ooh, okay. Well, it almost works. I see the floors. I don't see the walls. What did I do? Oh, I probably put them black and black, right? I probably messed up the colors. No. Oh, 0.1 instead of 1.0. Okay. Let's try again. Refresh. There they are. Wow, that's bright. Okay, and I can see me kind of moving around, but I can move through the walls, and I did see that the next part was making the wall solid. Okay, so we got that working. Cargo format, get diff. All right, so here's our new map section. This is all the map stuff we did. All right. Oh, format spread this thing out. That's fine. There's the draw, and there's where we insert. Okay, looks good. Probably should run Clippy in the build script, but I'm too lazy to edit it right now. Status git add source, git commit -m, drawing, creating, and drawing a map. Good. And now we want to make the wall solid. Oh, but before I do that, I wanted to... It would have been faster just to type in that command. I wanted to see if I can create this and then pass them in. I don't know. There's rules about ownership, and it might be passing in the ownership if I just create one. Let, I don't know, gray equal RGB from F32 0.5, 0.5, 0.5. I'll just do that one and see if that works. If that works, I can do the rest, right? Oh yeah, it worked fine. I thought maybe if I was passing it in and ownership would change. But maybe this is doing a copy for us. Black is, let's just do this. Black is 0, 0, 0. And then we have green equals 0, 1, 0. And then what's our other color? Oh, that's it. All right, so this is gray and black. And this is green and black. And then we can say let floor equals this. And wall equal that. Gray, black, floor. Oh. And wall. Does that work? Does it still run? It does, and we can regenerate the map every time we hit refresh. Nice. All right. Does it make it less spread out? Yeah, look at that. XY, gray, black floor. XY, green, black wall. Looks a lot nicer that way, I think. So, git add source, git commit, refactor, colors, and glyphs. Sure. All right. So we're having fun now. Okay, so now if you run the program, you'll have a green, gray map with yellow @ who can move around. Unfortunately, you'll quickly notice the player can walk through walls. Fortunately, that's pretty easy to rectify. To accomplish this, we modify the try move player to read the map and check the destination is open. So what does it look like now? Try move. There we are. So we have positions and players, and then we can grab the map. So that's new line. For each player position, we look at the destination of where we're trying to go, and then we look in the map to see if it's a wall. If it's not a wall, then we just move the player. Otherwise, we ignore it. Okay. I think we can still leave the player being read storage. Let's add this. That map is ECS fetch vec tile type, right? And we still do this. Let dest is equal to xy_idx pause x plus delta x pause And we're going to be doing it again. Right? All right, we'll just, that's fine. Plus delta y. Right? And then if map des is not equal to tile type wall, in other words, if it's a floor, then we do that. Pos x min 79, that hasn't changed. I was wondering why these weren't lining up, but it looks like there's an extra space in there. That's fine. Okay, so now we should be able to bounce off walls. Let's build that. Let's go here, hit refresh, and now if I go, oh, I can't go into the wall. Boom. I can go up and hit, okay, look at that. Very nice. I can still walk through these monsters. They haven't gone away. Very cool. Oh, they took. Oh, interesting. I didn't even notice that the last. Oh, they did not. They took out this left mover stuff that we did last time. All right, we'll get there. The full program now looks like this. Yes, it does. Slightly differently, but it's there. Cargo format, get diff. Yep, that's exactly what we did. Clippy is still happy. It is. Git add source, git commit. Okay, player cannot move through walls. All right, we're doing pretty well here. We got this chapter done, 2.2. We only have 100,000 more chapters left to go. Wow, look at all this. Cursed items, magic spells, enter the dragon, and then we get to shrooms. That'll be fun. All right, so that's where I'm going to call it for now, and thank you for watching. I'll see you later.